Now, after the failure of the Bohr's atomic model, alright, but let me tell you, here I am using the word failure, but actually, Bohr's atomic model you'll be seeing it that in the quantum atomic model we'll be using it once again, but leaving behind certain facts like will not consider atom to be two-dimensional. We will not consider what you can say about the hydrogen particles only. We will go beyond that also. We will also consider the Zeeman and the Stark effect. We will consider it and we will move forward. Alright. So hence I should say that Bohr's atomic model is not completely discarded, but the concept is discarded given by Bohr. What was the concept given by Bohr? It was discarded that atom is nothing but two-dimensional and electrons is moving around the atom with a fixed amount of energy which is stationary. Electron is not stationary, energy is stationary with a fixed amount of energy. Alright, clear, and it has got a certain fixed number of electrons in a particular shell. This was the few things in short I said you given by Niels Bohr. Many other things was given, but these are the few things. Alright, given by Niels Bohr. Alright. Apart from accepting the Niels Bohr's atomic model was that the Niels Bohr for the first time told us about the stability of the atom, mind it. For the stability of the atom, for the first time he told us. Stability means he was the first person to calculate the energy, alright, of an electron in an atom. He was the first person. He gave us the formula En is equal to minus 2 pi square me4z square by n square h square. Accordingly, we calculated the energy in the ground state. Just now I was speaking to you. So in this way, completely we cannot discard his theory, because from every concept we need to learn something and we need to move ahead. Niels Bohr was the first person who gave us the radius of an electron from the nucleus. Rn value we calculated, radius of a particular shell. Niels Bohr was the first person, so to say, to give us the velocity of an electron in a particular shell. So a lot of things he did. We cannot completely discard all these things. But few things, the conceptual part we can discard it and we can move forward. So hence I use the word failure. So don't think that Niels Bohr's atomic model, why did I explain you so as to say you that Niels Bohr's atomic model was not completely discarded. It is not completely discarded. Leaving behind few things, we accepted the Niels Bohr's atomic model. The few things means, again I repeat, the conceptual part we discarded it and we moved forward. Got it? Clear? Because the better science says about the spectroscopic method says us that apart from the spectral series we have got the finer spectral series also. Okay, so let us move forward. Now that is the development of Niels Bohr's atomic model. What you find is that it took place from the Planck's quantum theory. Isn't it? If you remember it, that is after the Rutherford's atomic model, I gave you the electromagnetic wave theory, then I gave you the Planck's quantum theory. The drawbacks of the electromagnetic wave theory came from the Planck's quantum theory. So the birth of the Niels Bohr's atomic model took place from the Planck's quantum theory. Similarly, I am going to say you now about the de Broglie's dual nature of matter as well as Heisenberg's uncertainty principle. Alright, this took place, or this gave rise to a new model that is called quantum model of an atom. Quantum, or it gave rise to a new mechanics that is known as quantum mechanics, we can say that. Alright, it gave rise to a quantum mechanics, we can say. A new model it gave rise to. A new concept it gave rise to, we can say that. Clear? Fine. So understand? So hence here we cannot ignore that de Broglie's concept or the Heisenberg's uncertainty principle, because this will give rise to a new concept, a new model, that is quantum mechanical model or the quantum mechanics, what you can say it about it, which you are going to study later on. So hence we are starting from de Broglie's, what you can say, concept. What I said, de Broglie's concept of dual nature of matter. De Broglie's, de Broglie, alright, de Broglie's concept of dual nature of matter. So what de Broglie suggested us? He said that every material object like this pen, alright, which is moving, the pen is not moving of course, the car which is moving on the road, a ball, when a bowler bowls towards a batsman, that also is moving, alright, a football is moving, a bus is moving, a train is moving, an electron is moving, alright. So all these, the macroscopic particles as well as the subatomic particles, the microscopic particles, electron, protons and neutrons, alright, he said possess dual nature. That is, it is having both particle nature as well as wave nature. Listen carefully. According to de Broglie, all the material objects in this universe has got dual nature. It is both particle nature as well as wave nature. Alright, that is whether a car moving on the road, whether a train is moving on the track, whether a ball is moving on the field, whether an electron is moving on a shell. Alright, so every particles, alright, material particles, whether it's macroscopic or microscopic, whether it is macroscopic or subatomic particles, they possess dual nature, that is both particle nature as well as wave nature. Alright, it possesses. Now we have to prove it, this particular thing. Of course we know it. It was said by Einstein also. He said us that it is an electron is of dual nature. That's particle nature as well as wave nature. He said us. From black body radiation, from photoelectric effect, from electromagnetic wave theory, we came to know about it. Alright, it was said by Einstein already. Now, the new thing which he added, the de Broglie is going to add is the mathematical relationship. The new thing which he is going to add it. Alright. Now, according to de Broglie, see, he said that according to Planck's quantum theory, we know it that E is equal to h nu. Understood the concept? What he want to say? That every material object in this nature is of dual nature. From there he started. It's both particle as well as wave nature. So from the Planck's quantum theory, we know that E is equal to h nu. We know it. From the Einstein's mass energy relationship, we know E is equal to mc square, or rather I should say E is equal to delta mc square. Now both are E, we can equate it. Both are energy, na? We can equate it. So h nu is equal to mc square. Now nu means, what is that? C by lambda. We have read it. C is equal to nu lambda. So nu is equal to C by lambda. We have studied. So instead of nu, I can put it. Nu means frequency. C by lambda. C is the wave velocity. Lambda is the wavelength. Alright. mc square. Mass into, here this C stand for what? The velocity of light. Here m is the mass. And C is what? The velocity of light, which is 3 into 10 to the power 8 meter per second. Alright. Find it. Mind it. Here also same thing. C. Velocity of light. So understand it, what I am doing it. So 1c I can cancel it. So I get it h by lambda is equal to m into c. Now mass into velocity. What is mass into velocity? Momentum. We have studied already. Momentum, linear momentum. So h by lambda is equal to p. Now h is a constant, isn't it? Planck's constant. So what I can say is that instead of this I can write it that p is inversely proportional to lambda, because h is a constant here. H is a constant. So I can say that is p is inversely proportional to lambda, or lambda is inversely proportional to p, whatever it is, both the same. Alright. So in this way, this was said by de Broglie. Now we'll analyze it, we'll understand it, this particular further. That means according to de Broglie, that is every material particle which is moving has got a momentum. Definitely, it has got mass, it has got velocity. Mass into velocity is nothing but is your momentum. It has got momentum. Now, what I find is that momentum is inversely proportional to wavelength. That was said by de Broglie. It's proved also. You can see it is inversely proportional to wavelength. That means if a body has got larger wavelength, it has got a very smaller momentum. If a body has got a very smaller momentum, it has got a very, what you can say, a smaller wavelength, then it has got a very larger momentum. Now which body has got larger, or what you can say, maximum momentum? Like a truck. The mass of the truck you see, and the velocity which is moving you see, you multiply it and see, it is having a larger momentum. Alright, mind it, a mass of the truck, it's around some 1000 kg or something like that, it may be. Alright, clear? Or a bus, or a car, or a scooter, alright, or a cycle, or a train, whatever it is. The mass is much larger than that of an electron, we can say that. Clear? So mass into velocity, if you multiply, then you will be getting the momentum value is huge, large. Now if the momentum is more, the wavelength will be less. Got it? But for a subatomic particle, the mass is quite negligible. For an electron, it is 9.1 into 10 to the power minus 31 kg. Into the velocity of the electron, which is nearly to that of light, we can say that. Clear? Which is nearly what? It is same as that of light. 3 into 10 to the power 8 if you multiply it. Then the momentum is very small, so wavelength is large. That means what you can conclude, that de Broglie's dual nature of matter, de Broglie's, listen carefully, de Broglie's dual nature of matter is has nothing to do with our day-to-day life, because it has nothing to do for macroscopic particle. It has to do with microscopic particle. Now why did I say it has nothing to do in day-to-day life? Because in a day-to-day life, are you dealing with electron, protons or neutrons? No, you are not dealing with electrons, protons or neutrons. Are you dealing? I will say this is an electron, this is a proton, this is a neutron. Are you dealing? A common man is dealing with electron, protons or neutrons? No. Even a chemist also is not dealing with electrons, protons or neutrons. It is dealing with atoms or molecules, we can say that. Not also atoms, molecules we can say that. Because atom does not exist independently. How an electron will exist? Clear? So hence, de Broglie's dual nature of matter, de Broglie's concept has nothing to do in our day-to-day life. Let me say you that. Alright? It has something to do with what you can say subatomic particles. Now, I'll explain this. To explain this, so hence what you find is that you understood the fact that if a body is having larger momentum, then the wavelength is very small, very small, negligible. And if a body has got a smaller momentum, then the wavelength is very large. So which body is having larger momentum? The macroscopic particle, which is having larger momentum, so the wavelength is negligible. And in case of subatomic particle, the momentum is smaller, so the wavelength is larger. If it is larger means what I mean to say, it is visible. At least if it is not visible to the naked eyes, it can be visible through a microscope. But when a car is moving on a road, are you seeing the car or are you seeing the wave? Now you come to the point. Alright, when a car is moving on a road, when a bus is moving on a road, when a bowler is bowling towards a batsman, the batsman is seeing the ball or he is seeing the wave? He is seeing the ball. When a car is moving on a road, you are seeing the car. Are you seeing the wave? No. That's it what I am saying. Why the wave is not visible? Because wavelength is so small. You will see it, I will prove it now. When the wavelength is so small, it is not visible. So that reason I said that de Broglie's concept has nothing to do in our day-to-day life, because the wavelength is so small. Now how much it is? Let us calculate it, then you will understand it much more better. Alright, let us calculate it. Okay, let us calculate it, this particular part. So that is, let us say lambda is equal to h by p, h by p. So is equal to h by p is nothing but mass into velocity. So h is 6.626 into 10 to the power minus 34. Mass of, let us say a ball I am taking, a ball, got it, of mass 0.1 kg. Alright, mass I am taking to be as 0.1 kg here. Listen carefully, 0.1 kg. I am writing it as mass I am taking to be as 0.1 kg. Alright, and the velocity with the ball is moving is, let us say, let me take it 60 meter per second. Let us say 60 into. So if you see 0.1 into 60 is 6. So, and this is 6.626 and this is 6. So nearly it gets cancelled. Okay, for that reason I do, because it will be easy for me to calculate. 0.1 into 60 is 6 and this is 6.626. So nearly it gets cancelled. Nearly. So what you find is that approximately you get it the value to be as 10 to the power minus 34 meter. Because we have taken 60 meter per second. So approximately lambda you get it to be as, let me make lambda, otherwise you will not understand. Lambda to be as 10 to the power minus 34 meter. Yes or no? See, calculate it. Lambda is equal to h by p, h by mv. I put the value of mass and velocity, which nearly comes to be 6. I have cancelled it, and approx, I have written approx, the value is 10 to the power minus 34 meter. Now tell me, when a ball is moving with a speed of 60 meter per second, we can say that. Clear? Will it be ball is visible or a wavelength is visible? This wavelength will be visible to you. This wavelength will be visible to you. By any powerful microscope also it is not visible. It is not visible to the naked eyes. Forget about it. But it is not visible by a powerful microscope also. Hence, I said the de Broglie's concept is based upon, de Broglie's concept which he gave us is true for, or it is valid for subatomic particles. It has nothing to do with the particles which is there in our day-to-day life, like this, what you can say, this macroscopic particles. I said for that particular reason. Alright? Clear? It is true for subatomic particles, mind it. Here, instead of this 0.1, if I put the mass of the electron 9.1 10 to the power minus 31 kg, and if I put the velocity of the electron, which is 3 into 10 to the power 8, you will see this particular value comes to be larger than this. It will come to be around 10 to the power minus 5 or 10 to the power minus 4 meter. Of course, it is visible by a powerful microscope. Got it now? De Broglie's concept. What is de Broglie's concept? A dual nature of matter. It is valid for subatomic particles. Alright, but apart from this de Broglie, gave us some more clarification, as I said you earlier. Now we are going to see that particular one.